going to continue with multiplication, but instead of multiplying monomials, we're going to multiply bigger things. So again, this is just review Algebra 1 concept. So we're going to have 3x to the 5th times the quantity of negative 2x to the 4th plus 6x to the 3rd minus 5x. So in this scenario, I have a monomial times a trinomial. I know I have a trinomial because I have 3 terms and they're separated by plus or minus signs. Whenever now you have something times something bigger than a monomial, we are now going to distribute in. I'm going to take that whole 3x to the 5th and I'm going to distribute it in.
Sorry.
It's okay. So now don't forget your rules for multiplying. Did it work, Sean, or no?
Yeah, it worked.
Okay. 3x to the 5th times a negative 2x to the 4th. Multiply your coefficients. We get a negative 6x. Keep your base. Add your exponents. X to the 5th times x to the 4th is x to the 9th. Then we have 3x to the 5th times 6x to the 3rd. That is going to be 18x to the 8th. 3x to the 5th times negative 5x to the 1st is negative 15x to the 6th. No like terms to combine, so we stop right there. All right, let's do the same idea, but now add variables as exponents. So y to the 3n times the quantity of y to the n plus 2y to the 2n plus 4. Once again, I am going to distribute. Y to the 3n times y to the 1n. Remember, keep your base, add your exponents. What's 3n plus 1n? 4n. Y to the 3n times 2y to the 2n is going to be 2y to the 5n. Good. Y to the 3n times 4 is just 4y to the 3n. Again, no like terms, so we stop it here. All right, you guys do this one. So that's negative 10 a to the n, b to the n, times the quantity of a to the n, b to the n, minus 7ab plus 8. You guys are trying that on your own, and then we will go over it. All right, check your answer with somebody next to you. Plead your case if you got different answers.
Oh no, you're right. That's what I have written too.
All right, tell me some answers that you got. Tell me some things that you got. Angie. I'm sorry, I can't hear her. Boys, shh. Say it one more time, Angie.
Negative 10 to the, or negative 10a to the 2n, b to the 2n plus 70, a to the n plus 1, b to the n plus 1, plus, oh wait, no, negative 80, or minus 80, a to the n and b to the n.
Anybody get anything different? Every person got this.
Well,
Antonio.
I got negative 10a to the 2n, and then b to the 2n, and then plus 70a to the 2 plus n, and then b 2 plus n, and then negative 80a and bn.
Hey, anybody get anything different?
Negative 10, a to the 2n, b to the 2n plus 10.
Hold on. Negative 10, a to the 2n, b to the 2n. Minus 10, a to the n, b to the n. Did anybody get anything different? All right, let's see who's right. So we are going to distribute this in. Do we all agree this is a to the first, b to the first here? All right, so negative 10 times 1 is just a negative 10. Everybody got this. A to the n times a to the n is a to the 2n. B to the n times b to the n is b to the 2n. Every single person got the same first term. All right, now let's keep going. Let's see what happens with the second term. So now we're going to have negative 10 times a negative 7. Negative times a negative is a positive, so we got positive 70. Then we have a to the n times a to the first. Remember, keep your base and do what with your exponents? Add them. So this is n plus 1. Then b to the n times b to the first is b to the n times b to the first is b to the n plus 1. Sean, was it Sean? No, Antonio, right? Who said it? Antonio.
I was green.
You were green.
Yeah.
Where did we get the 2 plus n from?
A times a is a over 2, or a to the 2.
Okay, do you see how it's n plus 1?
Not really.
Okay, because I don't really see how you're getting the 2. All right, tell me again. So when we're doing a to the n times a to the first.
Yeah, so like a times a is a squared.
But it's not a times a, it's a to the n times a to the first. There's the n. So you keep your base. So if this was a to the third times a to the first, you'd say a to the fourth. You wouldn't say this is like a, do you see what I'm saying? You just take whatever exponent it is and add it. Does that make more sense now? Okay, good. All right, so now let's see. Let's keep going. Negative 10 a to the n b to the n times 8 is a negative 80 a to the n b to the n. So the first answer was the right answer. What happened here?
We forgot to add the 1.
Okay, gotcha.
For the final answer, would you have to pull a 10 out?
No, so multiplying, we're not factoring. So like we're not trying to pull things out because we just put everything in. Then we'd end up pulling everything out that we just put in.
Oh, yeah.
All right, now let's talk about this. tell me why this is wrong. So I took the quantity of 9 minus 2x squared, and I raised that quantity to the second power. And I'm telling you 81 minus 4x to the fourth is wrong. Or, yeah, that's wrong. I want to know your name. Next to Sean, what's your name? Anthony. Okay.
It's the whole thing by itself, so everything in the set of parentheses times another set of parentheses.
So that's what I did. I just made it twice. So that's why there's the 81 and the 4x to the fourth, because I squared it.
Okay, that's fine, but it's like the set times another thing of the set, so.
But why not? When I had this, I made this. What's the difference?
That's the whole thing. It's weird.
I know what you're saying. I'm being annoying on purpose because I'm looking for. Yeah, he agrees that I'm being annoying. That's so mean. All right, I'm looking for something else. Hasini?
It's since there's two terms, you have to multiply like both the two terms by the two terms, not each of the two terms separately.
Yeah, but like if you're saying the same thing Anthony said, so then I could it's the same thing. Look, if I did this, 81 x to the second y to the sixth. Well, I'm just distributing it in. You want to try again? No. Next to Angie is Caitlin.
It's a binomial, so you have to multiply each number to each other.
Okay, that's what I was looking for. This is a different process because it is a binomial. I was being annoying because I wanted to hear that word. What are these? Monomials. So can I distribute in for a monomial? Yes. Can I distribute in for a binomial? Yes. I'm happy with everybody. Everybody knew that we couldn't do it. I was just looking for that specific word. So now we want to actually multiply this out. So we're going to do it twice. So we're going to say 9 minus 2x squared times another quantity of 9 minus 2x squared. And you can FOIL. I always use double distribute. Whatever it is that you like, you use. 9 times 9 is 81. 9 times a negative 2x squared is a negative 18x squared. Then we double distribute the negative 2x squared. Negative 2x squared times 9 is a negative 18x squared. Negative 2x squared times a negative 2x squared is a positive 4x squared. I'm going to combine my 4x to the fourth. Thank you. Good catch. I'm going to combine my like terms and then put it in descending order. So we're going to have 4x to the fourth minus 36x squared plus 81. If you didn't put it in descending order, you're fine. What's up?
Do you always want our answer in descending order?
Whatever you want. It's fine. Generally in algebra, that's sort of how it goes. It goes in descending order, and if there's multiple variables, it's like alphabetically in descending order. Okay, what about this? A plus 2 times A plus B plus 1. So in this scenario, you can't FOIL, right? Because it's not a binomial times a binomial. So your only option is, I guess, triple distribute. So A times A is A squared. A times B is AB. A times 1 is A. But now I'm going to triple distribute the 2. 2 times A is 2A. 2 times B is 2B. 2 times 1 is 2. We combined our like terms, so A squared plus AB plus 3A plus 2B plus 2. And like I said, addition's commutative, so any order you wrote this would have been fine. right, you guys do this one. That wasn't number 6. That was 5. All right, compare with a neighbor.
Yes. Oh,
actually, no. I think that's part of all.
Yeah, we got the same answer.
I don't mind the
Oh, but then you remember the X is squared.
but I mind all that.
All right, tell me, what did you get? Give me some answers. Give me some answers. Up front, what's your name?
Abby.
Abby.
I got 5x to the third plus 20x y to the second minus 20x to the second y.
All right, any other answers? This could be in any order, by the way. This could have been in any order. Nobody got a different answer. What if I told you this was wrong? Then would there be different answers? Oh, now there's a different answer?
No. I
Okay.
actually wasn't listening. Sorry, but I just noticed that I got something different. I got 5x cubed plus 20x squared y minus 20x squared y.
That's what she
no,
said.
Not y squared, x squared.
Oh, x squared y?
Yeah. So.
And then another 20x squared y? Say, read.
No. No, one's plus. So yeah, that's fine.
It's the same?
Yeah.
Okay.
Good job,
Yeah. What'd you get?
5x to the power of 3 minus 20x squared y plus 20x y squared.
That's the same answer.
It's confusing.
It's just different order. Just different order. Okay. This is all right. This is all good. This was the right answer. I was just teasing. I was just making sure people weren't being shy. All right. So that is the end of multiplying polynomials. Let's talk on to synthetic substitution. All right. So at this point, primarily what you've been dealing with is direct substitution. So let's talk about direct substitution. So direct substitution is something like this. Evaluate 3x to the third plus 10x squared minus 5x minus 4 when x equals 2. Well, you are all very familiar with this. What we're going to do is anytime we see an x, we're going to substitute in a positive 2. So this becomes 3 times the quantity of 2 cubed plus 10 times the quantity of 2 squared minus 5 times 2 minus 4. Once we directly substitute in our value for x, now we're going to simplify, and when we're simplifying, we want to make sure that we're following PEMDAS. So we're going to do exponents before anything else here. So we're going to have 3 times, what's 2 to the third power? 8. What's 2 to the second power? And now what I'm going to do is I'm going to take care of all my multiplication simultaneously. So 3 times 8 is 24, 10 times 4 is 40, negative 5 times 4 is negative 10. And now all we're left with is addition and subtraction. So I'm going to go ahead and I'm going to say 24 plus 40 is 64. 64 minus 14 is 50. That is direct substitution. That's what you guys are all used to. Let's talk about synthetic substitution. We're going to do the same problem, but now with synthetic substitution. Okay, what we want to do, step number 1, when we're using synthetic substitution, is make sure every exponent is accounted for in descending order. Okay, let me tell you what that means. So I'm going in descending order. My biggest exponent is 3. Since my biggest exponent is 3, in this polynomial, I need an exponent of 3, I need an exponent of 2, I need an exponent of 1, and then a constant term if it exists. Let's say there wasn't the 5x there. Let's say it was just 3x to the third plus 10x squared minus 4. You would have to put a 0x to represent that placeholder for the exponent of 1. So you want to make sure every exponent is accounted for in descending order. If an exponent is different, put a 0 in front of the missing variable and exponent. Okay, once you make sure that every exponent is accounted for, what you're then going to do after that, you are going to list all of the coefficients out. Write all coefficients / constant without the variables. All right, so I'm going to show you what that looks like now. So write this down. Write all coefficients / constant without the variables. All right, are we ready? So I'm going to write it in a row. 3, 10. What's the next one? -5, not +5. That's a -5. And then -4. 3, 10, -5, -4. The number we're going to substitute in is going to go in a box. So we're going to substitute in 2, right? So I'm going to put 2 in a little L-shaped box. Put the value you will sub in as an L-shaped box. Okay, so now what you're going to do after you've done that whole setup, now we're going to start solving. We are going to bring the first coefficient down. Bring first coefficient down. Then multiply that number with the number in the box. Put the product in second column and add. I'll let you guys write that down and then I'll show you what I mean. Everybody have it? And done? Okay. So what do I mean by this? So what we're going to do is we're going to bring that first number down. And I said take that number and multiply it with the number in the box. So 3 times 2 is 6. That's going to go in the second column. And what am I going to do? Add. 10 plus 6 is 16. We're going to repeat this process. So step number 4, repeat the process until the last column. Can I go back up? Okay, so now we're going to keep going. 16 times 2 is 32. -5 plus 32 is a positive 27. 27 times 2 is 54. -4 plus 54 is 50. The number in the last column after you add is your answer that would happen if you did the direct substitution.
Like, what's the point of this?
In some scenarios, it's a quicker way to do direct substitution. It's a quicker way. And this is going to, down the line, like months from now, we're going to do synthetic division, which this will then come back into play. So it's just another option for direct substitution that makes it in times a little bit quicker.
Okay.
Sure.
This is too hard.
Like right here is good? We're going to do more.
2 times 27.
Angie, we good? Still? Okay. Am I doing on time? Okay. Okay, let's do another one. So I'm going to tell you to evaluate 2x to the 4th minus x to the 3rd plus 5x plus 3 when x equals -2 using synthetic substitution. So on the test, I'm going to say times you have to use synthetic substitution. Yes?
So, like, do you need, like, an x squared?
We do. Very good. So Antonio's like, there's something wrong here. You have x to the 4th, x to the 3rd, then x. We're missing an x squared. So what we're going to do is we're going to have 2x to the 4th minus x to the 3rd plus what? 0x squared plus 5x plus 3. Now we good? Yeah. So I'm going to put the -2 in the box, and then I'm going to list my coefficients. 2, -1, 0, 5, 3. Bring down the 2. 2 times -2 is -4. -1 plus a -4 is a -5. -5 times -2 is 10. 0 plus 10 is 10. 10 plus -2 is a -20. 5 plus a -20 is a -15. -15 times a -2 is 30. 30 plus 3 is 33. What's wrong? Did I lose a number?
No, I'm confused. How do you get the 10 in the third column?
-2 times -5. -2 times -5 gives us the 10 here. 0 plus 10 is 10.
And then in the next one, so we're always multiplying by -2?
Yeah, you always multiply by the number in the box.
Oh, I didn't do that.
So let me show you a scenario. We're not going to actually do the problem, but let me show you a scenario where this would be preferred for you over direct substitution. So let's say I gave you 3x to the 5th minus x to the 4th plus 2x to the 3rd minus 5x to the 2nd plus x minus 3 when x equals 15. Be a little bit brutal, right? Plugging in the 15 here and simplifying. All right, so in this scenario, we're not going to actually do this problem because even direct substitution is a little brutal. I mean, even synthetic substitution is a little brutal, but I'm just showing you. When push came to shove, if you had to do this, synthetic would be the better option over direct. All right, try. I'm not going to give you this one to try on your own. I'm going to give you a different one. Try this one on your own. 3x to the 5th minus 10x to the fourth plus x to the third minus plus 5 when x is 3. And I want you to use synthetic.
When you need the x squared and the x 1.
Good. This time, how many am I missing? 2. So it would be 3x to the fifth minus 10x to the fourth plus x to the third plus 0x squared plus 0x plus 5.
You need more 5. I got the correct answer. Hold up, I haven't done it. Hold up. You're throwing me on my train of thought.
All right, I don't actually know the answer to this, so I don't know if you're going to tell me what's right or wrong, to be honest. We'll have to go through it. Let's see if everybody has agreed. Wait, do you guys want to consult? Consult.
Yo,
I actually like this one way more than direct.
All right, give me some answers. Like I said, I do not know the answer. Sean, what'd you get? Negative 49. Did anybody get anything different? How many people got negative 49? Then I'm just going to believe you all that it is negative 49. Okay, we are done for the day. No homework. Happy weekend.